Okay, question 11 on paper 2H gap analysis. Gillian bought a new speedboat 3 years ago. That's nice there. At the end of the first year, the value of the speedboat had decreased by 7.5%. I'm going to pick up my calculator and I'm going to think, well, I start with 100% and I'm going to take off 7.5%. So I've now got 92.5%. So that as a multiplier is 0.925. You're not going to use a multiplier where we start increasing by 7.5%. We're using the multiplier it's describing in the question. The value of the speedboat then decreased by 20%, so I'm going to pause, that is 80% less, so it's 0.8 as my multiplier for each year for the next 2 years. Right, this is a percentages question, so I've got new is the original times the multiplier to the power of time. That's my general equation I'm going to start with. At the end of the 3 years, the value was, so this is my new value. I don't know what my original amount was, but I do know that to start with, this happened to it. It was decreased by 7.5%, and then it was decreased by 20% twice. So now I'm going to rearrange 15392 divided by all of this here. And I'm just going to take that over as it is and put that into my calculator. So 15392 divided by 0.925 times 0.8 squared. And I get 26,000. Work out the value of the speedboat when she bought it 3 years ago, £26,000. Okay, question 12. Isaac and Kerry each take their theory driving test. The probability Isaac will pass is 0.9. So I'm just going to make myself a little note that means that probability fails is 0.1. Probability that Kerry will pass is 0.75. So probability that she will fail is 0.25. Complete the tree diagram. Well, it's 0.9. This is Isaac. Pass and fail 0.1. So it'll be 0.25 there. Kerry pass 0.75 and fail 0.25. Work out the probability that only one of them will pass the driving theory test. Well, that can happen if Isaac passes and Kerry fails, or Isaac fails and Kerry passes. So we're going to go across our tree diagram and we're going to multiply. And we've got these two, so it is an OR situation, so we add them. So on your calculator, we're going to do 0.9 times 0.25. We've got 0.225. 0.1 times 0.75 is 0.075, and we're going to add those two together, which is 0.3. Question 13. Okay, there'll be a few different ways of doing this. I'm actually just going to multiply through first. So I've got 5 to the n times by 5 to the 18 is equal to 5 to the 16 times by 5 to the power of 7. Now my rule here is that I would add the powers, and I would add the powers here. So this is going to be 5 to the power of n plus 18 is equal to the 5 to the power of 16 plus 7, which is 23. And all we want to do now is take these two, because I've now got the same base number, I can equate them. It must mean that n plus 18 equals 23. So n is going to be 23 minus 18, so n equals 5. Part B. This means we are going to cube root and then square. So I'm going to start off by writing that. So I'm going to cube root this, and then I'm going to square it. Cube root of 27 is 3. The cube root of 15, y to the power of 15, well, when you're cube rooting, it's the same as doing power of a third. The rule here would be that we would multiply the powers, so 15 times a third, or a third of 15, is going to be 5, which makes sense. If I do y to the 5 times y to the 5 times y to the 5, that's going to give me my y to the 15. So I have now cube rooted it, and now I want to square it. So I'm going to square the 9, and I've got to do y to the power of 5 squared. I shouldn't have scribbled that out. Y to the power of 5 squared is doing y to the 5 times y to the 5, which is y to the power of 10. Question 14. We have got something to do with a box plot by the look of it. So for a box plot, I need the minimum, the maximum. So I've got minimum, maximum, median, lower quartile, upper quartile. So I need to check that I've got all that information. Lowest age is 15, so my minimum is going to be 15. I'm actually just going to add that onto my diagram. So I've got my minimum. Highest age of 75. I've got my maximum, 75, is up here. Lower quartile, 26. Upper quartile, 48. Median, 32. In fact, they're not even making us work anything out on this. That's it. We had everything that we needed. Something to remember on box plots is that each section is worth 25%. So that's worth 25%, 25%, 25%, 25%. Work out an estimate for the number of these gym goers, gym members with an age between 26 and 48. Well, 26 and 48 is my lower quartile to my upper quartile. It's that whole section there, this whole bit here, which means that's 25%, 25%, so that's 50% of the people are in that section. 50% are between 26 and 48. There are 40 members of this gym, so we want to do 50% of 44, so I'm going to divide it by 2, same thing, 22. Ella says at least one of the gym members is 32 years old because the median is 32. Is Ella correct? Okay, so for this one, there are a couple of ways you can think about it. There'll be a few correct answers. 32 could be an average, it could be a mean of two numbers. So, no, 32 could be the mean of two numbers, because we'll have the kind of middle two numbers. You could say that we've got 44 people, so of course if we've got 44 people, we've got an even number of people, so you've got two numbers that you've got to find the mean of. Just because the median is 32 doesn't mean that anybody was actually 32. It could be that either side of the middle was 31 and 33. So anything kind of along those lines should be fine. Question 15. The two bottles are mathematically similar. So similar, this is our scale factor, is big divided by small. Before I even start, I'm going to run along with this. I'm going to say I've got linear scale factor, I've got an area scale factor, which is my linear scale factor squared, and my volume scale factor is my linear scale factor cubed. I'm going to look at my values here. I've got two volumes here, so this is going to give me my volume scale factor, 1680 divided by 120. Get on your calculator. 1680 divided by 120 is 14. So that's my volume scale factor. Before I do anything else, I am going to work out the rest of my scale factors. My linear scale factor is going to be the cube root of 14, and my area scale factor is going to be this number squared. So I'm going to now do the cube root. So cube root of 14 is this number, 2.410, etc., etc. And my area scale factor is going to be that number squared. 2.41 squared, which is 5.808. I don't know which one of these I'm going to need, but it's always a good idea to have them all ready to go. Work out the height of the smaller bottle. So I need to divide by the scale factor. And my linear scale factor is this one here. So my height is going to be 15 divided by 2.41, etc. So I get 6.2229, etc. I know it says correct one decimal place, I would now round it 6.2. The surface area of the smaller bottle is A. The surface area of the larger bottle is PA. So this is my scale factor times A. It says find the exact value of P. So exact value makes me think we're going to be using something to do with thirds. However, 14 doesn't look like it's going to be particularly nice to go into a third at all. Right, so let's have a look. In order to work out the surface area, we would need to know what the scale factor is. It wants to know the exact value of P. Well, P is just my scale factor. I've talked about my scale factor already. So to get from my 14 to my area scale factor, I cube rooted and then squared. So look how many marks this is worth. It's only one mark. We know it is the cube root of 14 squared. This, as an index, is 14 to the power of, well, the cube root is the 3 going into the denominator, and the squared goes up here. So this is it, 14 to the power of 2/3. However, they do also accept this as the answer. Okay, moving on. Question 16. There are some sheets of paper in a pile. The height of the pile is 9.7 correct to the nearest. So correct to the nearest, I'm just going to pause and make myself a little note that this is going to be a bounds question. So I'm thinking about upper and lower bounds. So the height is 9.7 correct to the nearest millimetre. Nearest millimetre, this is my millimetre part. This is in centimetres, this is my millimetre. So I'm going to call that 70 for a second. I'm going to split it. I'm going to have my 9.65 and my 9.75. So those are my values that I'm going to use. I've kind of used that bit of information. The thickness of each sheet of paper is 0.16 correct to 2 significant figures. So I'm going to put myself on a 0 on the end here. That's now 160. So it's 155, 165. That is a way of thinking about it. I've used that information. Calculate the lower bound for the number of sheets in the pile. So if I was going to do this, I need to know how many of these go into this. So I'm going to do division. So I would have my height divided by my pieces of paper, the thicknesses of my pieces of paper. And I want the smallest possible value. When I do a division, to get my lower bound, I need my smallest, my lower bound, divided by my upper bound. So I'm going to do my height of 9.65 divided by 0.165, and that should give me my answer. 9.65 divided by 0.165, 58.48. Lower bound of the number of sheets, well, number of sheets is going to be 58. Apart from that, doesn't make any sense. Sorry everybody. This is in centimetres, I should have put it in millimetres, shouldn't I? That should be 97, and that should be 96.5. Apologies. Let's now do that again. Doesn't make any sense. So it's 96.5 divided by 0.165. There we go, that's a bit more reasonable. Is 584.8. So 584 or 585. Okay, circle theorems question. Let's try and get easy marks to start with. It says write down any circle theorems you use, so we do need to make sure we do that. Find the sides of angle OBC. O to B to C is this angle in here. That's ultimately what we're going to find. But find out anything we can to start with. So I can see very clearly I've got myself the sort of rocket shape in here, which means the angle at the centre is double the angle at the circumference. So I can start with that DOB, angle DOB, is going to be 2 times 75. I'm going to show all my method in case I make an arithmetic error. So 2 times 75 is 150 degrees, which is now this one in here. And write down these circles there. Do it as you go. So angle at centre is double angle at circumference. Now I'm going to do something else. So now I can see that I've got here a cyclic quadrilateral. cyclic quadrilateral, opposite angles are up to 180. So BCD is going to be 180 minus 75, which is 105 degrees. And that is opposite angles in a cyclic quadrilateral add to 360. So now I know this one here is 105. The last bit that we're trying to find, angle OBC, is now inside a quadrilateral. It's not a cyclic quadrilateral because not all of its vertices are on the circumference. But we do know angles in a quadrilateral up to 360. So I'm going to do 360 minus 150 minus 105 minus 41. 360 minus 150 minus 105 minus 41 is 64 degrees. I need to make sure, I know it says about writing any circles here, but I'm actually going to make sure that they know that I've used angles in a quadrilateral add to 360. Okay, and the final question, question 18. C is a circle with centre 0, 0. I personally am just going to quickly sketch myself a circle, terrible circle. The straight line with equation. Now, personally, I don't really like it looking like that. I am going to rearrange that to get y equals mx plus c for a moment. I don't know if I need to, but I'm going to do that to give myself a bit of a helping hand. So I don't like this being negative, so I'm going to put it over here. I'm going to add 2y to both sides, and I'm going to take 87 off both sides. So 1y is going to be, if I divide it all by 2, 2.5x minus 43.5. I've done this so that I can just kind of roughly see where my line is sitting. So I've got a negative y-intercept and quite a steep gradient. So I think I'm looking for something looking like that. My x, that's my y. The straight line with equation in the is the tangent to the point at P, so it's now going to be point P is here. I know that this is minus 43.5, and what might be useful to me, I don't know, but it might be useful to me to find out my x-intercept as well. So I'm going to say that when y equals 0, let's find out what x is so we can do this bit. So 2.5x minus 43.5 equals 0. 2.5x equals 43.5. And I get x equals 17.4, like that. Okay, so I know equation of a circle is x squared plus y squared equals r squared. We don't know what the radius of this circle is, but we can now substitute some things in. So I've actually already rearranged this to make y the subject. So I'm going to put this into here. So I've got x squared plus y squared equals r squared. Okay, so this is me thinking aloud, and actually this is no good to me because I've still got too many unknowns. I don't know what the radius is of this, so I'm going to scrap that idea. And what I'm going to do instead is I'm going to look at gradients. So this is kind of a good thing. It's kind of pointing out sometimes it's a good idea to try and start something even if you're not sure and see what happens with it. So on this one here, I want to work out my gradient of this line. Well, I know my gradient of this line is 2.5 because I've already done a bit of rearrangement. So my gradient is 2.5 or 5 over 2. That means that the gradient going here is going to be negative 2/5. These two are at right angles to each other. The tangent is at right angles to the radius. So what I can now do is I can use this to help me. I know that the gradient of this line is my negative 2/5. I also know my y-intercept of this line is 0 because my radius, this is circle at centre origin, so my y-intercept is going to be 0. So I've got the equation of this line now is y equals minus 2/5 x. That is the equation of the radius where it goes through at P. And I've got my equation of my line here, y equals 2.5 x minus 43.5. Oh, I've written equals y. And now I can solve these simultaneously. So what I'm going to do is I'm going to substitute y in for here. Minus 2/5 x equals, and I'm actually going to write that again, I think it's 5 over 2x minus 43.5. Do a bit of rearranging to get my x value, so 43.5, 5 over 2x plus 2/5 x. So 43.5 is equal to, if I use common denominator, although this is calculator paper, so I could use calculator. Right, so 2.5 plus 0.4, so I've got 2.9x. So if I do 43.5 divided by 2.9, I get my x value of 15. I'm going to think logically, does this make sense? I've worked out where my x-intercept is, it's 17.4, so an answer of 15 seems reasonable. Once I've got my 15, I need to know what y is. Well, y is going to be, you could substitute into either, but you may as well go into the nice easy one with the fewer numbers. Negative 2/5 times 15, 1 and 3, y equals negative 6, y equals negative 6. Look, does this make sense? I've found this information and it makes sense that if it's going to be close up to the 17.4, i.e. x is going to be 15, that is going to be quite high up, so y equals negative 6.